So, here's one of the deepest questions in all of science, really. It sits right at the edge of the world we can measure and the world we experience. Is that feeling of being you? Is it something your brain cooks up from scratch, or is consciousness something more fundamental, something the brain just tunes into? These two ideas are at the heart of a huge scientific debate. So let's dive in and explore the evidence.
We live in an incredible age for neuroscience. We can literally watch the brain as it thinks and feels in real time. We have this amazingly detailed map of how it all works. And yet, all of that data, all those beautiful brain scans, they all kind of dance around this central mystery. The simple fact that it feels like something to be alive. With all we know, why is there any inner experience at all?
All right, to get our heads around this, here's our roadmap. We're going to start by framing just how big this mystery is. Then we'll look at the tools science uses and, crucially, where they fall short. After that, we'll survey 4 competing theories before we run into a paradox at the heart of science itself. And finally, we'll look at where this is all headed.
So, first things first, we have to be really clear that this is not just some late-night dorm room conversation. The problem of consciousness is now a serious, legitimate challenge for modern science. It's what's famously called the hard problem.
This quote from the philosopher David Chalmers just nails it. Okay, we can all accept that the brain is a physical system, right? It's made of atoms, it follows the laws of physics. But why on earth should a bunch of neurons firing create the richness of an inner life? Think about it this way. Physics can explain perfectly how a speaker vibrates and creates sound waves, but it has absolutely nothing to say about why those sound waves, when they hit your brain, create the feeling of joy you get from a piece of music. That gap, that leap from the physical process to the subjective feeling, that is the hard problem.
So how does science respond to a challenge like that? Well, a lot of researchers, like neuroscientist Anil Seth, take a very pragmatic approach. He says, look, let's set aside the ultimate why question for a minute and focus on what he calls the real problem. The idea is to just meticulously explain, predict, and control the properties of consciousness. It's a strategic bet, really. The hope is that by carefully mapping all the small connections, like how these neurons create the experience of seeing the color red, the bigger blueprint for consciousness might just reveal itself down the line.
And, this piece-by-piece approach has been incredibly successful. We can now map the links between what's happening in the brain and what a person says they're experiencing with just astonishing precision. But this success brings us to a really crucial distinction we have to make.
This is the world of what scientists call neural correlates. We can see the exact patterns of brain activity that light up when you see the color blue. We can see the different neural signatures for when you're awake, when you're dreaming, and when you're in a deep sleep. And we can see what happens when consciousness gets switched off completely. Anil Seth actually described his own experience under general anesthesia. He said he just ceased to exist. No time passed. There was just nothing. A complete and total absence of experience.
And what's really fascinating here is that these different states were mapped out with incredible precision long before we had brain scanners. The Mandukya Upanishad, for example, describes the waking state, the dreaming state, and then deep, dreamless sleep, a state it calls consciousness without content. This ancient framework actually reinforces a key scientific point. Our normal, everyday waking consciousness is just one of several different measurable modes of being. And it's this variety that science is now trying to explain.
But this all leads us to the fundamental limit of our current science. We can see when the brain shifts from waking to dreaming. We can see which parts of the brain are humming with activity when you feel happy. But mapping the when and the where just isn't the same as explaining the what. A brain scan of someone feeling joy is not the feeling of joy itself. And that forces us to confront a hard truth in this field. Correlation is not explanation. And this brings us to what might be the single biggest barrier in the science of consciousness. This gap between objective data and subjective experience. You could call it the third-person limit. Okay, think about it like this. On one side, you have everything science can measure from the outside. Brain signals, frequencies, voltages. That's third-person data. On the other side, you have the experience itself. The raw feeling of seeing red, the sound of a melody. That's first-person experience. It's like this. Imagine you have a perfect detailed blueprint of a massive cathedral. You can see every single measurement, every structural detail. That's the third-person data. But that blueprint can never ever convey the actual feeling of awe you get when you're standing inside it. That's the first-person experience.
So this really poses the defining question that divides the entire field. Is this gap just a temporary problem? Something that better technology and more powerful computers will eventually solve for us? Or is it a fundamental limit? A sign that a purely third-person objective science might never be able to fully capture a first-person subjective reality.
Faced with this pretty massive challenge, several competing scientific models have popped up to try and bridge that gap. We're going to walk through 4 of the most influential ones right now, keeping a neutral perspective.
So the first one, and probably the most standard view among many neuroscientists, is that consciousness is an emergent property. The idea here is that individual neurons aren't conscious, of course, but when you get billions of them together, organized in this incredibly complex network, consciousness just sort of arises from that complexity. The physicist Christoph Koch has a great analogy for this. A single H2O molecule isn't wet, but get enough of them together and you get the emergent property of wetness.
The second model, which is championed by thinkers like Anil Seth, views consciousness as a kind of controlled hallucination. Now, in this view, your perception isn't just a passive window looking out at reality. Instead, your brain is actively generating its best guess of the world from the inside out. It's constantly making predictions about what's out there. And the information from your senses just serves as a stream of error correction, fine-tuning that hallucination so you don't, walk into a wall.
Okay, Model 3 is Integrated Information Theory, or IIT, and this one makes a really bold claim. It says consciousness isn't some illusion or some side effect. It's a fundamental property of the way information is structured. It even proposes a mathematical value called phi, which is supposed to measure how much a system's whole is greater than the sum of its parts. If a system has a high phi, it means it's highly integrated. You can't break it down without losing information. And the wild implication here is that consciousness is graded, and any system with a high enough phi, maybe even a B, could have some little spark of experience.
Now, our fourth model flips the entire problem completely on its head. What if consciousness isn't something produced by matter at all? This view suggests that consciousness is a fundamental property of the universe, just like space-time or gravity. In this model, the brain doesn't create consciousness any more than a TV creates the show it's playing. It's more like a complex receiver, an antenna, that tunes into and processes a universal consciousness that's already out there. This idea echoes theories from physicists like David Bohm, who talked about a deeper implicate order from which our reality unfolds.
Okay, let's put these 4 models side by side and see where they shine and where they struggle. Look at emergence. It does a great job explaining why brain damage affects our consciousness. Simple enough. But look at the unanswered question. The cerebellum, a part of the brain with 80% of our neurons, seems to contribute almost nothing to conscious experience. Why this complexity and not that one? Now, predictive processing is brilliant at explaining optical illusions and why reality feels so subjective, but it still runs smack into the hard problem. Why should a best guess feel like anything at all? IIT gives us a mathematical reason for why some brain areas are conscious and others aren't, but actually measuring phi in something as complex as a brain is, for now, impossible. And finally, the fundamental model explains the raw fact of awareness itself, but it creates a brand new puzzle. If consciousness is universal, why is it so tightly linked to the very specific, fragile biology of a brain?
All of these models are trying to make sense of the data, but they all run into a deeper, more profound problem, a paradox that's really about the nature of scientific observation itself.
And this is where we hit a sort of philosophical wall that's built right into the scientific method. Think about it. Science is a tool that conscious observers use to study an objective world. But what happens when that observer tries to turn the tool around and observe itself? Consciousness is always the prerequisite for doing the experiment. It's the lens you're looking through, but it never, ever appears as an object under the lens.
This chart right here is a perfect example of the paradox. At first glance, it looks like pure objective data, a histogram showing frequencies. But the actual perception of this chart, seeing the black lines, the gray bars, understanding what the axes mean, that whole thing is an event happening in your consciousness. The data isn't just floating out there on its own. It only exists as an experience for an observer. Consciousness is the canvas on which all of science gets painted, and that makes it incredibly difficult to paint a picture of the canvas itself.
So where does all of this leave us? Well, facing this deep paradox doesn't mean science has failed. Actually, it's the opposite. It's a sign that science is maturing, that it's finally ready to take on its most profound challenge yet.
The study of consciousness isn't some fringe topic anymore. It has become an unavoidable central scientific frontier. We're seeing the birth of entirely new hybrid fields that are weaving together neuroscience with quantum physics and information theory with philosophy. The sheer difficulty of the problem is forcing a new level of collaboration, making us dissolve the old boundaries between different kinds of science.
And that leaves us with one final thought to chew on.
You know, most scientific questions, when you solve them, they just disappear into a textbook. They become part of our settled knowledge. But some questions are different. They're so fundamental that in the very act of trying to answer them, we are forced to expand our definition of what science itself is. The quest to understand consciousness might not just give us a new answer, it might give us a new kind of science.